Problem 238, product of array except self. So we are given an array of integers, and we have to return another array, let's call it answer, where each element would be the product of all of these numbers except for this element itself. What they mean is probably element with the same index. And they want us not to use division, right? Which means basically we cannot just calculate the entire product and then simply go through this answers array and divide the product by each of these numbers, right? So that sort of trivial solution will not work. We have to come up with something better. Now, they kind of give out a hint in this sentence here, how to solve this. They say the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. Now, this is a very strange sentence. I would say it's not a very professionally written sentence. I shouldn't have deleted this. Because the entire array is also technically a prefix. So if that fits in the 32-bit integer, then there is no need to say that the product of also every suffix also fits in a 32-bit integer. I don't know whether they somehow mean every prefix being everything except the kind of the last prefix. But anyway, whatever the convention they're using, we can solve this. And just a note, there is a follow-up, like a bonus question, where they ask you to use O1 extra space complexity, and we'll discuss that in the end, okay? Whatever they mean by this, etc. Okay, so I think an easy answer that they kind of hinted upon is that we could, before we calculate our answer, maybe we should pre-calculate. What? I've lost the cursor. Excuse me. Just let me. So perhaps we should pre-calculate. Okay, cursor is back. Prefix products. So, and also suffix products. So, for example, in here, for the prefix, I want to put the product of these two numbers. I mean, normally you would probably say that the third prefix would be actually this, right? That's what would go in here. But because of the nature of this problem, I would call this product 2 times 7 to go into this prefix. That would be easier than at the last step. I mean, here it's very easy to make this small change. And in the end, we won't have to do a whole bunch of ifs at every step. Okay. And then inside prefix, so for example, for this element, for this suffix, I think you've guessed it that I will put this product in here. Okay. And once this is done, our answer probably can be easily computed, right? So basically, this element inside answer would be the product of these two numbers, right? That would be our answer. Okay, let's try to implement this version first. So let's first create the prefix array, right? This is a numeric array of length of the same length as the original array. Now we could fill this with 1, but I think we don't strictly need this because the way we're gonna be filling this in. So I will make the first one equal to 0 because that will be the basis of our calculation. And then starting from the first element, not from the 0th element, from the index 1 element, and going through all of them, right? This is prefix length plus I. What I have to do is say, so basically what I have to do is make sure that prefix I equals prefix I minus 1 multiplied by nums I minus 1, right? Yeah, so each prefix would be the previous prefix, which is the product of everything that we've amassed so far, multiplied by nums I minus 1. So basically, the number that we're going to write in here is the number that we should have written here, which would be all of these previous ones, right? And then that multiplied by this number. That's precisely what goes in here. So that is correct. So prefix I equals that. That is fine. Now we should do the same for suffix. Constant suffix equals new array of type number. That's the number of elements. We're not going to fill it with 1 again. And this will just be exactly symmetrical. Suffix, the last one, so that is suffix length minus 1 is going to be set to, and that already means we need to make sure that this length is more than 0. So we have to make, let's say, if nums length. Well, we don't have to do this in this problem because I think we probably are given here that there are at least 2 elements. That's fine. But if there are no elements, I think if there is at least 1 element, then this should work. But if length does not exist, let's say this is 0, then we should return, I don't know, maybe throw an error or return an empty array. This will never really happen in this problem. So that would be equal to 1, all right? And then we have to do the same loop. Let I equals, now this time we're going to start from the penultimate element. So this will be suffix length minus 2. And then we're going to go through all of the elements, including the 0th element, right? And what we're going to do is suffix I. Suffix I is suffix I plus 1, okay, and multiply that by nums I plus 1. Same logic, right? So in order to write to suffix in here, we need suffix I plus 1, which we already calculated, and which equals the product of all of these numbers that came before it. And then basically we calculate it by this number. So this is this. And then if we calculate like that, we're going to get this number. Okay. That is fine. And now, if we were to return a new array, let's say array from length, nums length, right? So we take this new array, and the mapping function would be, so for each element, we could do, for each element I, we could do prefix I multiplied by suffix I. That should do it. Yeah. So by creating suffix and prefix in this slightly strange way, when instead of multiply, so to calculate the prefix, let's say here, instead of multiplying all of these three numbers, I'm just multiplying these two. So this is just to accommodate this particular problem, right? But because of doing this, now we can write this line in a more elegant way. Okay, so okay, that worked. Submit. Okay, that also seemed to have worked. All right. So now let's turn our attention to this little follow-up question. So can you solve the problem in O1 extra space complexity? Which means basically that we are not allowed to use these prefix and suffix arrays. These would be ON, space complexity. Now, answer array is also ON, space complexity, but they say this is fine. Using this array is fine, and the way they formulate this is the return array, the output array does not count as extra space. Well, that's very good, because otherwise I don't think we would be able to solve this problem with O1 space complexity, additional extra space complexity. Okay. So what can we do here? What can we do in a case like this, right? So let's say we're gonna create this answer array from the very beginning, and let's pre-populate it with 1, number 1 everywhere, right? That will be handy. Now we're gonna go through the nums array twice, once from left to right, and then from right to left, okay? So roughly the same kind of idea, but instead of calculating these prefixes and suffixes in separate arrays, we're gonna just try to use extra time complexity O1. O1 basically means we can use a few variables, not an array that would be dependent on the length of this array, right? But we could use, let's say, a variable called product, right? So I can initialize product to 1. Let's say, imagine that we are going in one direction first, yeah? So let's say we are going in, our direction is left to right, okay? So let's set product to 1. Remember that answer, inside answer, everything is set to 1. So that's kind of, everything's ready for multiplication. Now that product is 1, we could start this traversal from this element here. And along the way, we're gonna, like, the suffix is gonna get accumulated inside this product. So what we're gonna do is, first of all, we're gonna say product is equal to product multiplied, so itself multiplied by what? Nums I minus 1, correct? So if we're looking at this element here, then our product, which currently was 1, will be multiplied by nums I minus 1, so this number, yeah? But then also what we have to do is this answer itself, answer I, should be multiplied by that. I think that makes sense. So, okay, so there are two operations like this. So what that means is, first think about this. This will be executed first. So product will be multiplied by the previous nums. Okay, so if we are here, then we're going to multiply product by this previous number. Okay, so that will ensure that our product tracks, that will be basically the prefix, the product of all of these numbers before index I. Okay, because at every point we're going to multiply product by the previous number. So product will keep collecting, accumulating the actual product of all of these numbers except for the current one. And because we achieve this, because product is now the product of everything except for the index, well, the prefix, except for the current number, then we could multiply answer I, which is kind of 1 in this case. We could multiply this 1. We could just also assign it, but I mean, this is because when we are going the opposite way, there will be certain symmetry if we use this, right? It will be not as fast, but slightly more elegant, I would say. There will be certain symmetry. If that makes sense, then we will do precisely the same when we travel in the opposite direction. We're going to reset product to 1 again, and in here, instead of nums I minus 1, we will simply have plus 1, yeah? I plus 1. Okay, I think we should be able to implement this now. So let's get rid of the code that I had written. And let's do this. So we just initialize answer, right? So our answer would be, so we said new array of length nums length, and we have to fill it with 1. I think that's what we said, yeah. Yes, so now we need product, which so we were going to do passing from left to right. So let's create product and set it to 1. And then we said, let's do this loop starting from the first element. Okay, so for let I equals 1, and then I is less than answer length, and then plus plus I. So we're going to go through all of these. And we said to do this, answer I, product. So answer I is itself multiplied by product, which would be itself multiplied by nums I minus 1. Let's write this. So that's our first loop. And then when we come out from here, we say, well, let's reset product to 1 and go backwards, I being answer length minus 2, and then minus minus I. So here answer I would be itself multiplied by product, which is itself multiplied by nums I plus 1. And after that, we can just say return answer, right? So we just created one extra array and one product variable also I. So basically, this is our only additional on space, which they say doesn't count. And then the product variable and I, these are all 1, so we should be fine. Let's see what happens. Compile error. Semicolon expected somewhere. Let I Oh, right, of course. I is more or equal to 0, because we need every element here. Okay. Let's run this test. Do not remind me ever. Okay. Well, this also passed.